Welcome to this video in the Discover Mathematics series. In this video, we're going to use Algebra Tiles to introduce the idea of factoring trinomials. Okay, let's look at this first example. We have x squared plus 5x plus 6. So this is the product. And what we're looking for is what are the two factors that when we multiplied them together gave us this answer. So this is what's inside here. Under, we had something multiplied and something else multiplied. Two factors multiplied together, and this was the answer. Now the key to finding out what those factors are is to move these terms, these pieces, around to make a rectangle. So we don't have any choice with the x squared, and remember from the examples on multiplication that we'll put that one first. But if we leave all these together like so, what can we multiply? We don't know what we can multiply together, and we get these extra pieces that we can't, they don't make a rectangle. So what we are going to need to do is kind of split these up. So what we want to have is some over here, and we need to have some on the other side over here, so that when we fill it in here, the little ones will fill in. So if we have 3 here and 2 there, then these will fit. And if we try it in any other way, it's not gonna. Like if we had, let's see, we tried with 4. If we had 4 and 1, then the 4 fill in and make a rectangle, but we got 2 pieces left over. When we put it this way, I have 2 and 3, then we see that we come up with a perfect rectangle. So our factors, here's our x, plus 3, x plus 2, because x times x is x squared, x times the 1, 2, 3 works right there, and 1 times x is 1, 1 times x is 1, and then we have 2 here and 3 there, and that gives us our 6. So our factors, we would write it as x plus 3 times x plus 2. And it doesn't matter which one is first and which one is second. On the x plus 2 could be first or it could be second. But what is important is for students to realize that we're going to make a rectangle. Okay, let's look at another example. Okay, in this example we have x squared plus 6x plus 9. So I put all my pieces here, and now I need to fashion it into a rectangle. Now some students might think that if they put like 5 here, that makes the x, but it actually doesn't, because we don't know what the length of the x is, and we know it's not supposed to be, we're not supposed to think of it as an actual number. It's supposed to remain as an x. So we can't put the units to make the length of the rectangle. So we need to split them up so that we split up these so we can actually come up with a rectangle. So if we put 1 here, then that'll leave us 5, so we could place 5 here, but that's not going to be enough. So what we'll notice is when we put only 1, we get 5, but if we put 2, we actually can place more. We're super close, because we've got 8, and we still have 1 left over, But if we move another one over here, then we end up with a space for 9, because this is 3 by 3, and that gave us the 9. So our answer here is x plus 3. And on this side we have x plus 3. So we notice that we have the same factor on the top and on the side. And when that happens, when they're exactly the same, we notice that we come up with a perfect square. So not only is it a rectangle, it is in fact a square. And that's why we have, when this is x plus 3 times x plus 3, sometimes people will write it as x plus 3 squared, because it's the quantity. It means both of them are the same, but it also makes a perfect square. So we could write it x plus 3 squared. And in this next example, we have x squared plus 6x plus 8. And I want to see how I can make this into a perfect rectangle. So I need to move, if I move only one, then I have 5 here and 1 there. I can only take care of 5. I can put 5 there. If I put another one here, then I'll have 2 times 4, and that gives me 8. And I see that that does in fact work. So what is happening is I'm going to move these around so that I get numbers when I multiply this one times this will give me the number of units that I want. So in this case I get x plus 4 and x plus 2. So using the algebra tiles, it's helpful for students to start noticing a pattern. And one of the patterns that they'll notice very quickly, even though it takes a little practice, is that they want to split up this number so that they'll get two numbers that when they multiply together give us this last term. And that, in this case, gives us x plus 4 times x plus 2. So that's what we want them to see, that we need the two numbers when we add them together, that when we multiply them together, are going to give us this number here. But we want the students to figure it out for themselves instead of us telling them. So these were all the tiles were positive. Let's see what happens when we introduce some negatives. Okay, here I have x squared minus 5x, and I'm going to change that to plus a negative plus a negative 5x plus 6. So here I have my tiles, and I need to make a rectangle, and I notice that my last term here is positive. Now the only way I can get a positive is by multiplying two negatives together, and I have the negatives, so that's when I see I need to move, and if I only move one, it's only going to give me 1 times 4. It's not big enough, so I need to move a second one, And that gives me 2 times 3, and that's where I can fit the 6. We want the students to start noticing a pattern, but these, when I have the middle term negative, a negative times a negative, or here when I have the negative 3, and on this side I have, so it's a positive x and negative 2. Then I have my positive times a positive is positive. Positive x times negative 1 is the negative x. And that's how I got these 3 negatives. And here I have negative 2 times the x gives me negative 2. Negative 2 times negative 2 is positive 6. So that's how I got that answer. So I have x plus negative 3 times x plus negative 2. And then the negative 2 times the negative 3 gave me a positive 6. And my middle term is going to be negative. Okay, in this example, we have x squared minus 10x plus 16. And I want to make it into a rectangle, and I know that my 1's are going to have to fit in the corner. So let's say out of my 10, I take 1. And if I put 1 over here, then I have 1 times 9. Is that going to, are 16 going to fit there? See, that no, 16 is not going to fit there. So let me put another one. Now when I put another one, I have 2 times 8. Well, 16 fit there because I have 2 times the 8, and I realize, yes, the 16 will fit there. So that's what I'm going to put in here. But when the students do it with kind of trial and error, they're going to notice very quickly that that's what they're looking for. They're looking for 2 numbers. When they multiply them together, we'll give them the third term. So if we don't tell them the rules, and we give them the manipulatives and they figure it out, then they get a sense of accomplishment, success, and they remember it. But they're going to figure it out, and they'll figure it out for themselves. So here we have x minus 8 minus 8 and x minus 2. And it's a good idea for them to check, make sure that the multiplication is correct. So we have x times x is x squared, and x times negative 8 is negative 8x, and negative 2 times x is the negative 2x, and the negative 8 times the negative 2 is positive 16. So negative times a negative is a positive. Oops. Okay, so for these problems, I had the middle term negative and the third term is positive. Let's see what happens when the last term is negative. Okay, in this example, I have x squared plus 2x, and then I'm going to change this to plus a negative 8 so I can build it. And when I build it, you notice I have an x squared, and here's my 2x, and when I go to place in the negative 8 to make a rectangle, I can't. And even if I put one of these here and I put one there, the most I can place in is a 1. So it doesn't work. And initially it's just baffling. What do we do? Students might need a little help to realize that we need to introduce a zero pair. And if we introduce a zero pair, that's a positive and a negative. We haven't changed it because a negative x and a positive x is still 0, that's why I call it a zero pair. But it's going to help us fill this in. And if we remember when we did the multiplication, when we had the signs different, then the middle terms, when the signs were different, we got a zero pair and we removed them. Okay, so if we put in one zero pair, we see we only have space for 3. So I'm going to put in another zero pair. Now notice how I placed the zero pair. I put the positive with the positive, and then I put the negative with the negative. So I've introduced 2 zero pairs, and when I do that, now I have space to fill in my negative 8. This one should not be introduced on the same day when the previous 2 examples that I gave you, types of problems, because it's significantly different for the students, and they need to practice when all the tiles are when they don't need a zero pair before you introduce the zero pairs, because it's just more challenging and we don't want to frustrate them. But once they see here, when the last term is negative, they're going to have some zero pairs. They'll start to notice the pattern if you organize it so they can see a pattern. But if you mix all the problems together, there's no pattern, so they can't see a pattern. So here, what we want them to realize is when you have the third term being negative, you're going to have to introduce some zero pairs. And so here we have x plus 4 times x plus negative 2.